Good morning, students. Today we are to begin with the physics chapter, effects of electricity. Chapter 1, effects of electricity. Today we will be learning three topics under that: electricity and charge, electric current, and electric potential difference. So to begin with electricity. Dear students, as you know, electricity is an essential thing in our daily life. How the fans, tube lights and other things are working in your home, it is due to electricity. In offices also we need electricity to run computers, ACs and other gadgets. Even the big factories, they run with electricity to work their machines, to run their machines and big engines. So what is electricity? The answer to this question is, electricity is the energy by which the appliances such as bulb, fan, etc. are working. What is electricity then? How this energy comes in these wires in which the bulb is connected. It is due to the charge. The charge flows in these wires and then it becomes electricity. So the first thing, the charge. It is a fundamental thing. Charge is of two types: positive charge and negative charge. Can we analyze charge? Can we feel charge? Yes. You must have seen sometimes when you rub the plastic comb with your hair and bring it near the bits of paper, you will find these bits of paper are attracted towards the comb, plastic scale, etc. This is due to the charge. Some basic properties are there in the charge, that is, like charges repel each other and unlike charges attract each other. Charge can be in two states. First is, it can be static, as in the case of the plastic comb, or it may be in motion, that is dynamic charge. The dynamic charge is responsible for electricity. So electricity is produced when the charges move. The movement of charge in a wire is known as current. Current or electric current is constituted when the charges move inside any electrical conductor. The flow of electric charge in a conductor is known as electric current. The charge, as I told you, is of two types. So here the particle in which charge is formed, that is electrons. Electrons are the basic particles in which charge is present. The charge of electron is minus 1.602 into 10 to the power minus 19 coulomb. The unit of measuring charge is coulomb. C-O-U-L-O-M-B-S. Coulombs. So current, which is the flow of charge in a conductor. How to measure electric current? To measure electric current, we have one formula. The rate of flow of charge is called current. The symbol for current is I is equal to charge upon time. The unit of electric current. The SI unit of electric current is ampere. Its symbol is capital A. The SI unit of electric current is ampere. Now let us define ampere. 1 ampere. What will be 1 ampere? So in a wire, if 1 coulomb charge flows in every 1 second, in a wire, if 1 coulomb charge is flowing in 1 second, that is equal to 1 ampere current. So let us define 1 ampere. When 1 coulomb of charge flows through a cross section of wire in 1 second, it is called 1 ampere. There are some smaller units of ampere. They are milliampere and microampere. So let's learn smaller units also, smaller units of current. The smaller unit is milliampere. 1 milliampere is equal to 1 upon 1000 ampere, or you can say 1000 milliampere equals to 1 ampere. Similarly, 1000 microampere is equal to 1 milliampere, or 10 to the power 6 microampere is equal to 1 ampere. Whatever I am writing on the board, I advise you students to please write down in your notebook also the definitions. Because these constants you have to memorize in your mind, and I will be asking you the questions based on these constant values and definitions. Now the question is, how do we measure the current? The instrument to measure the current is ammeter. Ammeter is the instrument to measure current. Now the current has started constituted by the flow of charge in the conductor. How any charge will move inside any wire? What makes the charge to move? Do you know, whenever you have to use any torch, run the tape recorder or AC, you need some battery or a power source or electric switch. What is that doing? What is the role of the battery in any electric circuit? The electric circuit begins to give current by cell or battery. So the battery is source of producing current. What does the battery do in any electric circuit? It is the battery produces necessary electric potential. It gives EMF to the circuit. EMF, that is electromotive force. It is something which is pulling the charge and making it run through the wires in your domestic wiring. Let us understand this potential. How does water comes in your home? You will say there is a tank from where the pipe is there. Where do you keep the tank? The tank is always at the top. From there, the water flows down. Isn't it so? So, there is a difference in the height, then only the water will flow. If the tank and the tap both are at the same level, will the water flow? The answer will be no. Surely there is required one difference in the height for the water to flow down. In the same way, there is needed one potential difference of the charge for making the charge to flow in the conductor, and that is provided by the cell or battery. So let us understand that potential, electric potential. As I told you, two charges always repel if they are having the same sign. Let us consider that there are two charges, A and B. B has 1 coulomb charge. B is a positive charge of 1 coulomb. Now, because they are having the similar charges, they will repel each other. If you try to bring it towards it, you cannot do it unless you apply an external force. You do an external energy work. So, the work done in moving a unit positive charge and bringing it at any one point, that is the work spent. If it is not 1 coulomb, it is say any other few coulombs. In that case, the potential difference V will be the work done in order to bring the object from infinity to that point. So let us write the definition of electric potential. Electric potential, it is the amount of work done in order to bring a unit positive charge at any point in the the other charge. Electric potential is the work done in bringing a unit positive charge. You have to do an external work and that work. So what is the unit for electric potential? Surely it will be work done upon charge. As you all know, unit of work is joule and the unit of charge is coulombs. J oblique C. So the SI unit is volt. 1 volt is 1 joule per coulomb. This is the SI unit of electric potential. So let's recap what we have learned today. We have learned electricity, which is required by the appliances in homes and offices and factories. Then we studied electric current. The current, it is the rate of flow of charge. Then we studied electric potential, which is the amount of work done in bringing a unit positive charge from infinity to that point. The difference in the work done in between any 2 points is known as the potential difference. Potential difference. Potential difference, if potential at point A is VA and potential at point B is VB, so the potential difference between the 2 points A and B will be given by VA minus VB. It is the amount of work done in moving a unit positive charge from A to B. Let's solve some questions based on what we have learned today. So I have got some questions for you which I will be solving right here on the board. First question. Find the number of electrons which make 1 coulomb charge. Find the number of electrons which collectively make a charge of minus 0.2 coulombs. So, you know, charge of electron, let's solve it. Charge of electron, as I told you, is minus 1.6 into 10 to power minus 19 coulombs. If there are n electrons which are together making it equal to 0.2, so 0.2 is equal to n into E. Therefore, n is equal to minus 0.2 divided by E. Let us do it. N is equal to minus 0.2 coulombs divided by minus 1.6 into 10 to power minus 19 coulombs. Cancels. So this is 0.2 into 1 upon 1.6 into, this is going in the numerator, 10 to power plus 19. Now this is 1.6 0.25 into 10 to power 18 electrons. Now let's do the next question. There is a metal block from which electrons have been shed off. The number of electrons which have shed is 6.25 into 10 to power 18 electrons. What will be the charge on that metal block? So one thing we can easily tell that if negative charges are going out, then the neutral atom will become positively charged. Okay, so the metal will bear a positive charge. The magnitude can be calculated with the formula charge is equal to n into E. So n is 6.25 into 10 to power 18 into charge of electron 1.6 into 10 to power minus. I am sure you must have followed what I have taught you today, and now I am here with some interesting assignments for you. These assignments you can also download from our website and ERP, which can be downloaded from the mobiles. Students, please note down these questions. Calculate the current in a circuit if 500 coulombs of current flows through any wire in 20 minutes. Calculate the amount of current which flows through any wire when 500 coulombs of charge flows in 20 minutes. Next question is, write the SI units of charge. Write the SI unit of charge, current and potential difference. My last question is, calculate the potential difference when an 8 coulomb charge. Calculate the potential difference when an 8 coulomb charge is moved between 2 points and 200 joules of work is done. I repeat, calculate the work done, calculate the potential difference between 2 points when 8 coulomb of charge is moved between 2 points and a work of 200 joules is done. Thank you.